All right, these are just the key points that we've already taken a look at to refresh your memory on vertical asymptotes. So spend a minute or two here rereading just to refamiliarize yourself with what is meant, how we identify the vertical asymptotes, and also to remind yourself a little bit about how we determine the way in which the function behaves as the function nears the asymptote. And so we can make a table, we can just think about what the sign of the function is going to be as we get closer and closer to those asymptotes that we've identified. And then once you're ready, go ahead and press play and we'll take a look at an example together before getting some practice in. All right, let's begin by finding the x-intercepts, y-intercept, and vertical asymptotes of this function algebraically, and then we'll see if we can't put together a few things on how the graph might look. So let's start off with the x-intercepts. If this is something that has been a struggle for you, remember that the x-intercepts are the same thing, they're the roots, right? They're the x values that allow the y value to be 0. And so to find this, we're going to set our entire function, right, equal to 0. Set the y value equal to 0 and solve for x. When we have a rational expression set equal to 0, we know that simply means that the numerator must be equal to 0, because any fraction whose value is 0 must have a numerator that's equal to 0. And that's analogous to multiplying by the denominator on both sides of our equation and ending up with simply the numerator equal to 0. So I'll go ahead and do that. I have negative x squared minus 4x minus 3 equals 0. And I can use the quadratic formula, but I could also factor fairly easily. I have this negative out front. I'll factor that out. And what I'm left with inside is x squared. This will need to be a positive 4x. And this will need to be a positive 3 equals 0. And so now I can go ahead and factor, and this factors rather nicely. This will be x plus 3, x plus 1 equals 0, and therefore x must be equal to negative 3 or negative 1. And so this allows me to represent both of my x-intercepts as points. The first point is when x is negative 3, the y value obviously is 0, and when x is negative 1, the y value again, also 0. All right, let's move on to the y-intercept. So the y-intercept, of course, is the value, the y value, when the x value is 0. So I'm simply going to evaluate my function f when x is 0, and so I'm going to just substitute in 0 for x. And when I do so, I'm going to have 0 minus 3, so that will be negative 3 over, and then here I'll have 0 plus 9. So this will be negative 1/3, and therefore I have my point. The x value is 0, and the y value is negative 1/3. All right, let's move on now to the vertical asymptotes. So the vertical asymptotes, of course, are identified by finding where the denominator is 0, meaning where our function would be undefined because we can't divide by 0. So we will set our denominator x squared plus 9 equal to 0. And hopefully you identify visually that this quadratic equation has no real solutions, since something squared will always be positive, and a positive plus a positive will never be 0. So no real solutions, and therefore there are no vertical asymptotes. All right, so if you think about the information we have so far for our graph, we know that it's going to be defined everywhere, right? There's no values I need to exclude that would make division by 0 occur. And I do know that there are 2 x-intercepts, 2 roots, and I know what the y-intercept is going to be. But if all you were to do is put that information on a graph, we still wouldn't have quite enough information to determine what the graph is doing in between those x-intercepts and as you move far out to the left and far out to the right. So we do have some more discovery to do, but at least we are on the right track. Let's go ahead and get some practice with finding these 3 components. What I'd like you to do is go ahead and copy each of these down and find the x-intercepts, y-intercept, and vertical asymptotes of each of these functions. And if you want a little extra practice, what you might do is once you've found those, you might just sketch a little XY coordinate plane and mark down the information that you know and think about how you might examine what's happening as you approach those asymptotes, right? You could make a table of values. You could plug in some values in your head that are close to those asymptote values. But the important thing is that you identify each of these 3 key characteristics for these 4 functions. When you're done with that, I have one more problem for you, so press play and we'll take a look. Okay, so the goal here is to determine which sketch is the correct graphical representation of this function. Use the characteristics that we've been finding in this earlier in this lesson and previously, and mark those characteristics down on these graphs and see if they fit or do not fit. Don't be afraid to make a table of values to think about what's happening to your function as it's approaching those vertical asymptotes from the left and from the right. So in order, you can't just select which one. What you want to do is actually go ahead and find those key characteristics, and then on your paper, mark down those key characteristics for your graph, and that way you can pick A, B, C, or D.